Okay, in this session we're going to cover the topic 6, which is random variables and discrete probability distribution. We're going to cover the following in this topic. Mainly we're going to spend most of our time on the first point, which is first we will describe or we define random variables. What do we mean by this? I'm sure that we have used a lot of random variables in high school and in the first year in university. But now let's give it a formal definition. And then we'll talk about probability distribution. What does it mean? We learned in previous topic how to calculate probabilities, how to assign probabilities to the different events of an experiment. But that was the probability of one event. Here we're going to talk about, or we're going to expand more on probability. So we will have a set of probability values for one random variable, and this is what's known as probability distribution. Okay, we're going to talk a lot about that, and we're going to do some examples that show you how you create a probability distribution, which is very, very powerful. And I'm going to discuss later why it's very important. Then we're going to talk about bivariate distribution, where we describe the distribution or probability distribution of two variables. That's why we name it bivariate. And then we're going to learn about binomial distribution and Poisson distribution. These are very important, widely used in real life practice. We will talk about these in due time. So let's start with the first part. As we said, we're going to spend most of our time here. Random variables and probability distributions. Okay, so here is the formal definition given by our textbook by Kassar about a random variable. I'm sure that if you Google this term, you may find different definitions, but they all really boil down to the same concept. You can perceive random variable as being a function or a rule that assigns a number to each outcome of an experiment. Remember, we talked about experiments, which is any action that we may do or observe, and then we can observe different outcomes or different events that stem from this experiment. So here we go. We're going to use the same also here to define a random variable. So it comes as a function or the rule, and what's important is that we have a number assigned for every outcome. Now we have two types of random variables. We have the discrete and we have the continuous. And so what's a discrete random variable? A discrete random variable will take very limited number of values. Okay, so let's see these examples. When you flip a coin, this is our experiment, and then the outcomes. What are the outcomes? Let's say I'm interested in the outcome, which is the number of heads observed when I flip the coin 10 times. So this is the outcome that I'm interested in, and the rule is I want to observe a head that comes from the flipping 10 times. So what are the possibilities? What are the possible values for x? Here we have limited number of values because we are flipping the coin 10 times and we may observe no heads at all, and this of course can be very rare, but it is possible, so we have to put it on our list. And we can observe only one head, two heads, up to 10 heads. So in total we will have 11 possible values for x, and that's why we can comfortably say that this x, as we defined it, because you will be the one who will define your variable, okay, is a discrete random variable. Now, on the other hand, a continuous random variable can assume a very large number of values, very, very large. Yes, you may wonder, is it always that we cannot count it? Like here, the definition says uncountable, even when you can count it. But it is that large a number that you can also assume that it has a continuous distribution. All right, here we're giving an example that illustrates literally what do we mean by uncountable number of values when we define x as being the amount of water that every person consumes every day. You see here, I'm sure that unless if you are a very, very disciplined person and you measure every drop of water that you drink every day, then yes, the value of x in your case will be discrete, but in usually it's not, because we don't do that. So the volume of water can be any volume, right? So that's why this is a good example about a continuous random variable. All right, now that we defined a continuous and a discrete variable, let's talk about probability distribution. What is it? Again, we learned in previous topic how to calculate probability, how to assign probability to different outcomes. But now we are really interested in more. We're interested to summarize all possible probability values of one variable. So we put all these in a table and we call that a probability distribution. So, but it's not only in the form of a table. It can take the form of a formula, as you will see in future slides or in future segments. But also, very importantly, we will see it as a graph. And we're going to see that a lot when we talk about the normal distribution, which is a continuous distribution. This is very, very important. In fact, when we discuss the normal probability distribution, we will heavily rely on the graph, right? Because the table will be very large, and using the graph will be very useful for us when we solve problems. Now, just for the logistics part of dealing with probabilities and solving problems about probabilities of variable x, let's get familiar with these notations, which are widely used. So it's good to use the same convention. We usually denote a variable by a capital letter. Usually we use the letters X, Y, Z. You can use any letter, all right? But if you have only one, usually people use X. If you have two, it's X and Y, etc. It's not binding though. Now, the lowercase of this letter, we use it to denote a specific value, all right? So, for example, if x is, in the previous example, was the number of heads observed, so capital X would be the number of heads observed, and then small x can be 0, and then small x can be 1, etc. So that's very important for us when we start making statements about probabilities. So here we can see that, okay, let me get my pen here. Bear with me, please. Okay, here we go. So you see, it's P of x equal x, a specific value, right? Because x is our variable. It's a discrete variable, so it can take, let's say, 5 values, x1, x2, x3, x4, and x5. So here we're saying that we denote the probability that x will assume a specific value, let's say small x. Okay, this is how we write it. Or we simply denote it by p of x. So for example, we say the probability that we will see 2 heads, so we simply write p of 2. This will make our really statements or writing the different steps in solving problems about probability much easier than to use this notation. Okay, so we're going to use mainly this notation. All right. Now, as we learned before, now that we have defined the variable and we know how to denote its probabilities, let's remember again, how do we get these probabilities in the first place? Remember, we learned that in previous topic. For example, we learned the very powerful tool, which is probability trees. So this is how you get the values of the different, the probability of the different values of x. Because remember, what are the different values of x? These are possible events, all right, of that random variable. So we are familiar with that already. Or we can use the relative frequency, which is mostly used in different cases. Now, also, we learned these two rules, but let's remember, or let's get reminded again of these. The probability of any value of x should be between 0 and 1. Of course, you cannot get more than 1, not below 0, so please be careful about that. If for some reason you got a probability higher than 1, make sure that you stop and you don't continue. Make sure that you know what was the mistake. And the sum of the probabilities of all possible values, this is equal to 1. This is a very, very important characteristic of probability. All right, it's very important. We're going to use it a lot in our problem solving. Why? Because especially in discrete variables, when we can list all the possible values of x, then you will use this characteristic a lot whenever you want to answer some questions about probability of x assuming specific values.